One of the most common ways to change momentum is to collide two or more objects. The conservation of momentum states the total momentum before a collision equals the total momentum after a collision. Let's take a look at train cars. If the mass of each boxcar is the same, what will happen when they collide and stick together? So this train is going to come along and now it's stuck on that other train. They now have twice the mass. So they're going to keep moving, but with a slower velocity. Momentum can tell us how slow or how much slower. By using our momentum formula and the law of conservation of momentum, we can find exactly how fast or how slow these two cars will be going. Let's say that each car had a mass of 1,200 kilograms. The moving car came into the collision at a speed of 20 meters per second or a velocity of 20 meters per second. Calculate the velocity of the combined cars after the collision. We're going to set up each problem as a before and after situation. We'll list the mass, velocity, and calculated momentum vertically in each object. So we have before and after. Before, there are two objects. So there's two masses, two velocities, two momentums. Setting up these columns is very important. So before, I should have two columns. Always have a total momentum. So if you have two objects, you need to have a total momentum at the end. If you only have one object, like when the cars combine, then you'll have your total momentum automatically. So the cars are going to collide together. They both have a mass of 1,200 kilograms. The mass of car 1 and the mass of car 2, 1,200 kilograms. Car 1 is moving at 20 meters per second. So velocity of 20 meters per second forward. The second car is not moving at all, so it's 0 meters per second. I can find the individual momentums of both of these cars. 1,200 times 20 is going to give me 24,000 kilogram meters per second. That's the momentum of the first car. That's the product of its mass and its velocity. Well, if an object's not moving, it does not have momentum. However, if I do P equals mv for 1,200 times 0, I still get 0 kilogram meters per second. The total momentum is the sum of both of those together. 24,000 plus 0 gives me my total momentum. Afterwards, that momentum has to be the same. Conservation states that the momentum before, the total momentum before, is the same as the total momentum after. If there's two objects involved before and one object after, they both have the same momentum, so you have to add them up. So I have 24,000. The total mass is 2,400 kilograms, because when the two cars are together, we have 1,200 plus 1,200 to get 2,400. In this case, I can solve for the total velocity, the velocity that those two cars are traveling together. P equals mv, I know my total momentum, I know my mass, I'm just going to divide. 24,000 divided by 2,400 gives me 10 meters per second. So that means not only did the car slow down, the first car slowed down when it collided, it slowed down to 10 meters per second. Let's look at a couple pool balls. Billiards is a great example of momentum. Ball 1 has a mass of 0.5 kilograms. It's moving to the right at 4 meters per second. Ball 2 has a mass of 1 kilogram. It's moving to the left at 3 meters per second. After the collision, ball 2 moves to the right at 2 meters per second. What is the velocity of ball 1 after the collision? There's a lot of given information, so we need to make sure that we organize it well. So the two balls come at each other, go in different directions, and they bounce away from each other. Let's organize this into before and after. Before, there's two objects, there's two billiard balls. After, there's two objects, two billiard balls. So I need to have two masses, two velocities, two momentums before, two masses, two velocities, two momentums after. And both have to have a total momentum. If you have two or more objects, you need to have a total momentum as well as their individual mass, velocity, and momentum. Notice I labeled it as mass 1, mass 2, so I know that mass 1 is ball 1. Mass of ball 1 is 0.5 kilograms. So I'm going to plug in 0.5 kilograms, mass of ball 2 is 1 kilogram. I'm also given that ball 1 moves at 4 meters per second, ball 2 moves to the left at 3 meters per second. Forward is positive, backwards is negative. We usually attribute right to forward and left to negative. or backwards. So we make sure that that is a negative velocity. Think back to what we know about velocity. It has both magnitude and direction. It's a vector value. So I'm going to go ahead and find the momentum of each of those. I just do P equals m times v. 0.5 times 4 gives me 2 kilogram meters per second. 1 times negative 3 gives me negative 3 kilogram meters per second. The total momentum is the sum of those two together. 2 plus negative 3 gives me negative 1 kilogram meters per second. Momentum can be negative because velocity can be negative. Afterwards, we have the same total momentum. Momentum before equals total momentum after, even if you have multiple objects. Unless the objects stick together, the mass very rarely change. Either they stick together or they come apart. So I have 0.5 kilograms and 1 kilogram. They gave us some of the velocity information as well. Ball 2 moves to the right at 2 meters per second. So that's a positive direction, so it's positive 2 meters per second. This is where things become challenging. I need to find my next step, but it's not always easy to find. I can't find the momentum of the first ball because I don't have its velocity. I can find the momentum of the second ball because I have its mass and its velocity. Look at where you have enough variables or enough given information to solve for an unknown. So I'm going to take P equals m times v. Mass is 1, velocity is 2. Multiply those together to get a momentum of 2 kilogram meters per second. Again, look at what you have and look at what you need. I'm trying to find the velocity of the ball, ball 1 after the collision. We have a total momentum of negative 1. Ball 2's momentum was 2 kilogram meters per second. That total momentum comes from adding the two together. So P1 plus P2 equals P total. I can plug in and find that missing value. Total momentum is negative 1. Ball 2's momentum is 2. So I can just subtract 2 from both sides to get negative 3. So the momentum of ball 1 is negative 3 kilogram meters per second. It's asking me to solve for the velocity of the ball. I have not done that yet. So ball 1. Now I have its momentum and I have its mass. I'm going to plug those in. Negative 3 equals 0.5, which is our mass, times velocity. I'm going to divide both sides by 0.5 to get negative 6 meters per second. So that means that looking at ball 1's velocity, before it was going forward, afterwards it's going backwards. That's because ball 2 transferred its negative momentum into ball 1. There are two types of collision. Elastic, they hit and bounce off each other, just like the ball, or the two pool balls. So they hit and they bounce off. Inelastic, they hit and stick together. So that was the first example. We also can see the opposite of inelastic. When you see examples involving a bullet, it starts as one object, a gun and a bullet, and it ends as two, a bullet and a gun. A couple of big ideas to take away from today. Set up each problem as before and after. List vertically the known masses and velocities and calculate the momentums. Ask yourself if the masses are together or separate before and after. How many types of masses do you have? How many velocities do you have? How many momentums do you have? You always need a total momentum before and a total momentum after, whether you have one or two objects. Let's look at one more sample problem. So we have Kim holding a 2 kilogram air rifle loosely. She fires a bullet of mass 0.001 kilogram. Not a lot of mass, but a lot of momentum. The muzzle velocity of the bullet is 150 meters per second. What's the recoil speed of the rifle? On your own, try this problem.